Hello everybody, this is the part 2 of the video looking at the 2023 Higher Physics multiple choice paper. And as usual, I'm getting the paper from the Calder Glen High School webpage. There's the 2023 Higher Physics paper 1, and the answers are there as well if you want to check them. And every single past paper is there from the year 2013. So let's click on that. There it is. Remember, it's a 45-minute paper, 45 minutes for 25 marks. First thing you see when you open the paper is, of course, the data sheet. That contains all the usual suspects. That's the numbers that you might need when doing the calculations in the questions. And then we're going to pick up where we left off. That was question 15, and this picks up from the waves part of Unit 2, Particles and Waves. And this is a question about interference of monochromatic light. So, a ray of monochromatic light is incident on a grating, and the angle between the central maximum and the maximum observed at the edge of the screen is 29 degrees. And that 29 degrees is shown on either side of the central maximum in the diagram. The wavelength of the light is 605 nanometers, and the separation of the slits on the grating is 5.0 times 10 to the minus 6 meters. And we've to work out the total number of maxima observed on the screen. Well, we better start off with our grating relationship, m lambda equals d sine theta. And if we're looking for the total number of maxima observed, then it's m that we're looking for. So let's sub in everything else. The wavelength is 605 nanometers, and small d, that's the slit separation, is 5 times 10 to the minus 6. Times sine 29, and we're only working with 1/2 of the diagram here. And if you do the rearrangement on the calculator, then it'll be 5.0 times 10 to the minus 6 times sine 29 divided by 605 times 10 to the minus 9. And that gives you an answer of 4. And that means that there are 4 fringes on each side of the central maximum on the diagram. So let's draw them on here. There's the central maximum, and then 1, 2, 3, 4 on one side, 1, 2, 3, 4 on the other side, and that gives us a total of 9 bright spots. So the total number of maxima observed on the screen is 9. That's 15D. Question 16. Waves from coherent sources S1 and S2 produce an interference pattern, and maxima are detected at the positions shown. We're told the path difference between the two paths shown on the diagram is 154 millimeters, and we've to find the wavelength of the waves. So let's zoom in on this diagram here and see how many maxima we have, counting out from the central maximum. So there's the central maximum, then we've got 1, 2, 3, 4, and 5 maxima. So these two paths are meeting at the 5th bright fringe. And from your relationship sheet, the path difference is equal to m lambda. Therefore, 154 millimeters will be equal to 5 wavelengths. So one wavelength will be 154 over 5. That's 30.8 millimeters. And that corresponds to answer E. That's 2 questions in a row on interference there. Right, question 17. Which graph shows the relationship between the frequency f and the wavelength lambda of photons of electromagnetic radiation? Well, photons always travel at a constant speed of 3 times 10 to the 8 meters per second in a vacuum. So if v is constant, then if f increases, lambda decreases. There's an inverse relationship between the two. So which of those graphs is showing us an inverse relationship? It's graph A. B is showing us a direct relationship, and C and D are both increasing graphs, and E, although it's decreasing, it's not an inverse relationship, so 17A. Question 18. A ray of monochromatic light travels from a crown glass block into water, and the diagram shows 3 paths, P, Q and R, for the ray of light in the water. Which row in the table shows what happens to the speed and the wavelength and the path the ray of light follows in the water? Well, if we go to the data sheet here, we can look up the refractive index of crown glass and water, and they're 1.50 and 1.33 respectively. So the refractive index of water is less than that of glass. So that means when it goes from the glass into the water, it's going to bend away from the normal. So the only possible ray there can be P. And that narrows our options down then to answer B or answer E. And also because the refractive index of water is less than glass, then the speed of the light is going to increase when it enters the water. So there's our two options there. And if the speed increases, then the wavelength will also increase. So the only one where all three options are correct is option E. Speed and wavelength increase, and it's path P. That's 18E. Question 19. On to electricity here. An AC power supply of negligible internal resistance is connected to an 8 ohm resistor. The RMS voltage of the power supply is 5 volts, and we have to calculate the peak power dissipated in the 8 ohm resistor. Straight to your relationship sheet then. It's a National 5 relationship. P equals V squared over R. But we're looking for the peak power, so we need to use the peak voltage squared over the resistance. Now the peak voltage will be the RMS voltage times root 2, and don't forget to square it, divided by the resistance, which was 8 ohms. And if you do that in your calculator, you'll get an answer of 6.25 watts. The numbers in the question are only to two significant figures, so we round our answer to 2 sig figs, that's 6.3 watts. That corresponds to answer E, 19E. Question 20. Oh, this looks like another National 5 question. 6 36 ohm resistors are connected as shown, and we have to find the total resistance of the circuit. Well, the first thing we can do here is simplify the top and the bottom rows, because 36 and 36 is 72, and the total of the two 36 ohms in parallel in the middle section is 18 ohms. So let's redraw this circuit and simplify it with the 72 on the top and the bottom, and the 18 ohms in the middle. And then we just have to use our resistors in parallel relationship and do 1 over 72 plus 1 over 18 plus 1 over 72, and that will give you 1 over the total resistance. And then if you flip that upside down, you get the total resistance is equal to 12 ohms. That's National 5, adding resistors in parallel. Question 21. A student carries out an experiment to determine the EMF and internal resistance of a battery using the circuit below. The resistance of the variable resistor is altered, and readings of voltage and current are taken, and these readings are used to produce the following graph. And we've got the TPD on the y-axis and the current on the x-axis. And the thing to remember here is you'll get the EMF from where the graph cuts the y-axis. So if you extend that line, that's 6 volts. And you can find the internal resistance by working out the gradient of the line. So if we just pick 2 points there, so let's just pick our 2 extreme points. Then if we do y2 minus y1, that's 1 minus 5 over x2 minus x1. That's 2.5 minus 0.5. And you do that in your calculator, you'll get a gradient of negative 2. Now it's the magnitude of the gradient that's the internal resistance. So ignore the minus sign. The internal resistance is 2 ohms. So your EMF is 6 volts, internal resistance 2 ohms. That's answer E. You could also find the internal resistance just by doing the y-intercept divided by the x-intercept, which is 6 over 3, gives you your 2 ohms again. Question 22. 1 coulomb per volt is equivalent to? Well, if you have a look on the relationship sheet, you'll see a relationship that's got charge and voltage in it. And that relationship is Q equals CV. And if we rearrange that, we get C equals Q over V. That's coulombs per volt. And the C stands for capacitance, and capacitance is measured in farads. So 1 farad is 1 coulomb per volt. Question 23. Student makes the following statements about metals, insulators and semiconductors. Statement 1. In some metals, the valence and conduction bands overlap and each band is partially filled. That's correct. Statement 2. The band gap between the valence band and the conduction band in an insulator is large compared to the band gap in a semiconductor. That's correct as well. And statement 3. An increase in temperature decreases the conductivity of a semiconductor. That's incorrect, because an increase in temperature will decrease the resistance of a semiconductor. So it's 1 and 2 only. That's answer C. Question 24. A group of students carry out an experiment to investigate how quantity P depends on quantity Q, and the results of the experiment are plotted on a graph as shown. And as every good experimenter knows, once you've plotted your points, you should draw your best fit line through those data points. And notice, the graph does not go through the origin. Now, let's have a look at the question. A physics textbook states that quantity P is directly proportional to quantity Q, and the students make the following statements about the line of best fit that should be drawn using all the data points plotted. Statement 1. The line of best fit passes through the origin. No, it doesn't. The line of best fit does not pass through the origin. Well, that's correct. And statement 3. The line of best fit suggests that the measurements have been affected by a systematic uncertainty. Well, that is correct as well. So 2 and 3 are correct. That's answer E, 24E. Now the last one, question 25. It's another one of these unfamiliar relationship questions. And all you have to do here is sub in the numbers you're given and find out the unknown quantity, and in this case that's the mass m. So let's just sub in the values. So F is equal to 110. That'll be equal to the square root of T, which is 92, divided by 4m times L. And we're told that L is 0.63 metres. So let's square both sides to get rid of the square root sign. So 110 squared is 12,100, and that'll be equal to 92 over 4 times 0.63 is 2.52 times m. And then we'll rearrange it to find m. So m will be equal to 92 divided by 12,100 times 2.52. And you do that in your calculator, that'll give you an answer of 0.0030. Now we have to put that in the standard form. That's 3 times 10 to the minus 3, and that corresponds to answer A. And that's it then. Hopefully we got them all right. That's the 2023 Higher Physics multiple choice paper. And don't forget, do as many past papers as you can. See you in the next one.